Imagine a cosmic symphony played by an immeasurable number of stars, planets and moons, all playing in perfect harmony. However, there is one particular section of this orchestra that has perplexed astronomers for centuries. Exoplanets are not just planets. They are worlds that exist outside our solar system, hidden deep in the Milky Way. You might be surprised to learn that among the vast number of cosmic objects, there's an exoplanet so similar to Earth, so tantalizingly similar, yet enigmatic, that it could be our planet's celestial twin. We delve into the fascinating realm of Proxima b, located just 4.2 light-years away. The James Webb Space Telescope is revolutionizing our search for and understanding of these celestial enigmas. Imagine a moment where your mind travels across the vast astronomical realm of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. That's one with 15 zeros. To put this number in perspective, if each of these exoplanets were the size of a grain of sand, we would not only fill the Grand Canyon, but we would have enough to create a new geological monument on Earth, a Grand Canyon 2.0 that would stretch for miles. What is most surprising is that about 20% of these celestial bodies have been classified as Earth-like in terms of geological and atmospheric structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Along with these planets, there could be another quadrillion moons, rocky satellites similar to our moon, locked in gravitational dances with their parent planets. If you were to bet on the possibility of discovering another body in space that harbors life, or could do so, the cosmos offers an abundance of opportunities. Now that we have unfolded the canvas of cosmic scale, it's time to introduce the master, artist equipped to paint its intricate details, the James Webb Space Telescope. This celestial Sherlock Holmes, with its magnifying glass replaced by telescopic lenses, outperforms even the most advanced smartphone optics. We're not talking about just any lens. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Imagine the finesse. It can detect even the faintest flicker of a star billions of light-years away and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary is not only its observing power, but also its advanced technology, including infrared sensors and spectrograms. These tools can do much more than observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, composition, density, and even mass. Acting as a space forensic lab, they can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these questions, elevating it from a mere observer to an analytical genius. It's not just an advancement over its predecessor Hubble, it's more like a quantum leap. If Hubble's discoveries surprised you, get ready for a vertical feast of celestial revelation. Just as we've broadened our gaze across our complex landscape of the cosmos, it's worth focusing on one particular star in the celestial show, Proxima b. Since its discovery in 2016, this enigmatic planet has stood out like a Shakespearean protagonist, full of complexity and paradoxes, captivating astronomers and astrobiologists alike. What's all the fuss about? For starters, Proxima b is practically in our cosmic neighborhood, just 4.2 light-years from Earth. To put it in perspective, if you could beat the universal speed limit and travel at the speed of light, you'd get there in just over 4 years, about the same amount of time it takes for your favorite TV show to fall into decline or a presidential term to end. But let's dig deeper into why this proximity is so important. We're talking about a universe that stretches over 93 billion light-years from end to end. So finding a planet so close and so promising for scientific research is like finding a diamond in a pile the size of Mount Everest, a diamond that potentially holds secrets about life itself. In the grand tapestry of the universe, Proxima b is an intricate stitch, offering us invaluable clues that could redefine our understanding of habitability and life beyond Earth. It's not only Proxima b's proximity to Earth that excites the scientific community, but also the tantalizing clues that this planet is not only Earth-like but possibly Earth 2.0. Proxima b sits comfortably in what astronomers call the habitable zone, or Goldilocks zone, of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering rivers, vast lakes, and perhaps even oceans as deep and mysterious as the Mariana Trench. But before we start dreaming about vacationing on Proxima b, let's consider some of the peculiarities. For starters, a single day on this intriguing exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only herald a new day, but unfold slowly, resisting giving way to midday, and sunsets that stretch out too long, creating golden hours that photographers dream about. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adapt to the cycles of light and dark on Proxima b? Would we need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this very different world? The fundamental patterns of life as we know it would be at once tantalizingly similar and disconcertingly strange. It is as if nature is presenting us with a riddle wrapped in a conundrum, testing our understanding of what makes a planet habitable. You may wonder how we can obtain accurate and reliable data about worlds we have never visited. The James Webb Space Telescope deploys all its capabilities like a cosmic Swiss Army knife. More than just a telescope, it is a multifaceted research laboratory in the vacuum of space. Thanks to its innovative technology, astronomers not only observe planets, but examine them through a prism of analytical tools that would make CSI labs look rudimentary. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these remote planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific wavelength. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible existence of compounds essential to life, such as water, organic carbon molecules, and even oxygen. It's not just astronomy, it's space forensics. We don't wait passively for clues to come to us. We actively search for them, analyzing the atoms and molecules that make up these enigmatic worlds. The Webb telescope is not just an eye in the sky, but a highly specialized laboratory, analyst, and cosmic detective all in one. It allows us to turn our speculations and hypotheses about alien worlds into methods to confirm or disprove them. By expanding our views of the universe, it is revolutionizing our understanding of what might exist beyond our blue dot. Just when you thought you had unwrapped the most sensational layers of this cosmic onion, the story takes an unexpected twist. Just like in any science fiction thriller, researchers using the James Webb Space Telescope captured something extraordinary from Proxima b, a signal so unusual that it swept through the academic corridors and social networks, labeled as a possible techno-signature. It was an electromagnetic emission so complex and anonymously patterned that it could indicate the existence of an advanced civilization. The joint heartbeat of humanity seemed to stop at the climax of a revelation that promised to alter our perception of reality. Could the signal be the irrefutable proof that we're not alone in the universe? And just as quickly as it appeared, the signal disappeared, without repeating itself, without a trace, leaving behind not only an overwhelming silence, but also a maze of unanswered questions and bubbling theories. Was it simply a transient cosmic phenomenon, a fluke of celestial alignment, or something more deliberate, a coded message, or even a manifestation of a haunting cosmic essence? The solitary emission cast a shadow of enigma over Proxima b, stoking intense debate and speculation. Was it just a passing anomaly, or part of a cosmic narrative far more complex than we can imagine? The mystery lingers. But wait, the narrative, step of our cosmic exploration, is not yet complete. The ink has not yet dried and new chapters are still being written. This time it's not just ordinary scientists, but Harvard researchers who are leading a paradigm shift in our search for extraterrestrial life. They are not content with just scrutinizing the signals and phenomena we have discussed so far. They are upping the game by transforming the James Webb Telescope into a sort of cosmic night vision telescope. Their goal? to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're talking about staggering implications, such as the possibility of detecting terrestrial versions of cities glowing in the dark like luminescent pearls. Imagine seeing the radiant poles of what could be a metropolis, humming with the cadence of an advanced civilization, radiating its luminescence into the vast cosmic ocean. Let me know what you think in the comments box. If you liked the video, remember to like and subscribe.